Okay, so let's talk about quadratic equations today. Okay, quadratic equation means you have three real numbers a, b, c, and then the leading number a cannot be 0. Okay, yeah. And then we have three terms, a times x squared plus b times x, and the number c. So the right hand side of the quadratic equation, we always make it 0. Okay, make it 0. So this is a second degree polynomial equation. Okay, so ax squared plus bx plus c is 0 is a general form of the quadratic equation. Today we will learn three methods to solve quadratic equation. Okay, to solve quadratic equation. Okay, so the first method is factoring method. Okay, so if you have a quadratic ax squared plus bx plus c is 0, so we want to change this part to a product. Okay, to a product a times b equal to 0. Okay, so here a and b are linear expressions. That means degree 1, not degree 2. Okay, not degree 2. And then we will use this property. Okay, product is 0 if and only if a is 0 or b is 0. Then we get two linear equations, solve them, we can solve the quadratic equation. Okay, so the first method is factoring and zero product property. So now let's look at an example. Okay, so our first example is 2x squared plus x is equal to 1. Okay, is equal to 1. So what's the first problem you should notice here? This side is not 0. Okay, right hand side of this quadratic equation is not 0. So first you have to move all non-zero terms to left hand side. Okay, move everybody to the left. Okay, to the left. Then we get a quadratic equation. So what is a here? A is 2. What is b? B is 1 because this is 1x, and c is -1. Okay, so you have to change any given quadratic equation to ax squared plus bx plus c equals to 0. Change it to this general form and then factor it. Okay, and then factor it. So how did we get this product? Okay, for the left hand side. Okay, basically it's like trial and error. Okay, trial and error. So let's put it here. 2x squared plus x minus 1, only the left hand side, right? So how did you get 2x squared? So it's 2x and x. That's the only way you can get 2x squared, right? And then we get -1. So how did you get -1? So this is +1, the other is -1. Oh, this is -1, the other one is +1. Okay, and then you check it. Okay, you check it. So we have two choices. So first choice is 2x plus 1 times x minus 1. And then FOIL to check that. The other one is 2x minus 1 and x plus 1. Okay, so after your FOIL, number 1, you can see number 1 is wrong. So this is wrong. The other one is right. Okay, the other one is this quadratic polynomial on the left hand side. Okay, yeah. So if you cannot factor the left hand side like this, so you have to use method 2 or method 3. Okay, you cannot use method 1. If you can factor it and the solutions are very good, you can use method 1. Okay, yeah. So you can factor the left hand side is the condition for method 1, factoring and zero product property. Okay, so now let's use zero product property. Okay, step 3. Okay, so we got two. So this is our capital A, this is our capital B, so we got two linear equations. The A part is 0, or the B part is 0. Okay, the B part is 0. Solve the first one. So plus 1 plus 1. We got 2x is 1 divided by 2. We got x is 1/2. Minus 1 minus 1. So we got x2 is -1. Okay, so we got two solutions for this quadratic equation, 1/2 and -1. Okay, 1/2 and -1. Okay, yeah. So step 1 is very important. You have to make sure the right hand side or one side of the equation is 0. Okay, it's 0. So now let's look at another example, one more example. So let's see, we have x squared minus 2x minus 3 is 0. Okay, it's 0. So first you try to factor the left hand side, the non-zero side, right? So draw an arrow, x minus 3, x plus 1. Okay, yeah. So you can factor that. If you can't, just use the other two methods. Okay, just use the other two. But factoring is very important for the next part, rational equations or simplify rational expressions. Okay, yeah. So let me explain this factoring part again. Okay, factoring part again. So this is the easiest case about factoring, right? So A is one case. If A is 1, okay, so this is A x squared plus bx plus c is 0. So if A is 1, we can use what? X squared plus bx plus c is 0. Okay, and then we can use s and t, right? X plus s. We can assume the left hand side can be factored as x plus s times x plus t. So what's the product for what's the condition for s and t? So c is the product, remember? This is the product. And b is the sum. Okay, so we need s times t is c, s plus t is b. Okay, so for this particular example, what is c? C is -3, b is -2. So s is -3, t is +1. The order doesn't matter, okay? The order doesn't matter. You can choose s as 1, t is -3. You got the same expression, okay? Same expression. So if a is 1, my suggestion, you can try to factor it first. Okay, if you can. Factor it first and use zero product property. Otherwise, use from method 2 and method 3. Okay, so now let's use zero product property. So the a part, capital A part, capital B part, right? So we got x minus 3 is 0, or x plus 1 is 0. So plus 3, we got the first solution, x1 is 3. Minus 1, we got second solution, -1. Okay, so this is our first method, factoring method, and zero product property. Okay, so now method 2. Method 2 is called completing the square method. Okay, completing the square method. So let's look at the easiest case for the method 2. Okay, for the method 2. Okay, so let's look at this example. So let's solve this example. 3x squared minus 21 is 0. So why this example is special? Because you see there are only two terms. Which one is missing? The bx, right? So b is 0. So this is the condition for this special case. Okay, so if b is 0, we can take in square root. We can use square root to solve the equation. Okay, to solve the equation. Okay, yeah, so first you can try. You cannot factor this left hand side. Okay, so method 1 doesn't work here. Okay, so now move 21 to the left, from the left to the right. So we got 3x squared is 21. Divided by 3, we got x squared is 7. Okay, so now we get the last important step. Okay, we need to take positive and negative square root. Okay, so the last step. Take positive and negative square root to get two solutions. Okay, yeah. So x is positive and negative square root of 7. So x1 is positive square root of 7. x2 is negative square root of 7. Okay, yeah. So there are two numbers. The second power of them, the second power of positive radical 7. The second power of negative radical 7, they are both 7. So you have two solutions. Okay, you have two solutions. Okay, yeah. Now let's look at one more example like this. Okay, if b is 0. Okay, if b is 0. So if a is 1, try to use factoring. If b is 0, use this square root property. Okay, square root property. So let's look at this. Let's say 5x squared is 20. Okay, it's 20. So b term is 0, right? bx is 0. So divide by 5. Divide by 5. We got x squared is 4. So x squared is 4. Most students say, okay, x is 2. Then you lost a solution. Okay? So here, very important, you take positive and negative square root. So x is positive, negative, square root of 4. So x1 is positive, square root of 4 is 2. x2 is negative, square root of 4 is negative 2. Okay? It's negative 2. So we have two solutions, 2 and negative 2 for this equation, for this case. Okay, for this case. So now let's look at the second method. For b is not equal to 0. Okay, it's called completing square method. Okay, so completing the square method. Okay, there are two conditions, right? There are two conditions. So first, before you're completing the square, we have to get a is 1. We have to change a equal to 1. Okay, later I will tell you how to do that. Okay, how to do that. And then we need this number b, so b cannot be 0. Okay, b cannot be 0. If b is 0, just use square root property, right? Yeah. So if a is 1, b is not 0, so we can change this binomial x squared plus bx to a perfect square. Okay, to a perfect square by adding this number. By adding this number is b over 2 squared. Okay, b over 2 squared. You can FOIL the right hand side. You can FOIL this side to check. You will get the expression on the left. Okay, on the left. So now let me write it down on top of our example. So the completing square method, we want to change x squared plus bx to x plus b over 2 squared by adding a new number, b over 2 squared. Okay, so this is the completing square method. Okay, completing the square method. So let's look at our first example. Okay, our first example. So solve this equation, right? X squared plus 2x is 0. Okay, it's 0. So you can factor and then solve this. Okay, you can factor and then solve this. So now let's try completing square method. Okay, yeah. So completing square method, so what is our a here? A is 1, right? 1x squared. What is our b? B is 2. Okay, b is 2. So our goal is we want to change this binomial. We want to change this to a perfect square. Okay, perfect square. So now we add b over 2 squared on both sides. B is 2, so this is 2 over 2 squared, which is number 1. Okay, yeah. So left side and the right hand side plus 1. Then we got x squared plus 2x plus 1 is equal to 1. So now let's look at these three terms on the left. Okay, so the completing square method tell us this is equal to, these three terms is equal to x plus b over 2 squared. So now change left hand side to bx plus b over 2 squared. B over 2 is 1, so change this to x plus 1 squared is equal to 1. Okay, so nothing happened on the right hand side. Okay, nothing happened on the right side. Just change this trinomial to a special square. So now we take square root, positive and negative, square root on the new equation. Okay, new equation. So we got x plus 1 is square root positive negative square root of 1. So first case, x plus 1 is 1, positive square root, so x is 0. Second case, x plus 1 is negative square root of 1. So x plus 1 is negative 1, so that implies x is negative 2. Okay, negative 2. So this is the easiest example of completing square method. Okay, completing square method is not easy. Okay, it's very hard. Okay, it's very hard. So that's the key part. Okay, that's the key part of completing square method. So now let's look at one more example. Okay, one more example. Okay, so let's solve this example. Okay, solve this example. So first, x squared plus 4x minus 1 is 0. So what is a? A is 1, b is 4, and c is negative 1. Okay, c is negative 1. So our completing square method means we want to change ax squared plus bx, a is 1, sorry. So let's delete a part. Yeah, change x squared plus bx to x plus b over 2 squared by adding a constant b over 2 squared. Okay, b over 2 squared. So that's why first we have to get x squared plus bx first. Okay, yeah. So let's write down the equation. X squared plus 4x minus 1 is 0. So we need x squared plus bx only. So plus 1 plus 1. We got x squared plus 4x is 1. Okay, so now we need this completing square method, right? So a is 1, b is 4. So b over 2 is 2. B over 2 squared is 4. So both sides we have to add 4. Okay, we have to add 4. So add b over 2 squared on both sides. Okay, on both sides. X squared plus 4x is 1. So both sides we add number 4. So on the right we got number 5. What we will get on the left is this perfect square. Okay, it's this perfect square. So use x plus b over 2 squared on the left. So it's x plus 2 squared. B over 2 is 2, right? B over 2 is 2. So now take positive negative square root on both sides. So x plus 2 is positive negative square root of 5. So we got two solutions. First case, x plus 2 is radical 5 minus 2 minus 2. So x1 is negative 2 plus radical 5. Okay, second case, x plus 2 is negative radical 5 minus 2 minus 2. So x is negative 2 minus radical 5. So that's our two irrational solutions. Okay, so for this example, the first method doesn't work. Okay, factoring method only works for easy questions. Your S and T are integers or fractions. Okay, for bad examples like this one, you only can use either completing square method or the last one. Later we will talk about quadratic formula because the answers are bad. Okay, the answers are bad. So now let's look at if a is not 1, what should we do? Okay, if a is not 1, what should we do? Okay, so let's look at this example. 2x squared plus 6x plus 1 is 0. Okay, it's 0. So this example, there are some fractions. Okay, there are some fractions. I will show you the completing square method. It's not easy. Okay, it's not easy. So again, what do we need? Okay, what do we need? We want to change x squared plus bx to x plus b over 2 squared by adding the constant b over 2 squared. Okay, change the binomial to a perfect square. Okay, perfect square. So first we move the c, right? We move c to the right hand side. So we got 2x squared plus 6x is 1. Okay, is 1. So now a is not 0. You cannot do this. Okay, you cannot do this. So now divide by 2. Okay, divide by a. You will get x squared plus 3x is 1/2. Okay, so now we got this x squared plus bx part. We got it here. Okay, we got it here. So this is our completing square method for this ABC. Okay, for this ABC. So here our B is 3, A is 1. Okay, yeah. So before completing the square, you have to make sure there's no C part, A is 1. And then you can use B over 2. Okay, B over 2. So B is 3, so what's B over 2? B over 2 is 3 over 2, so what's B over 2 squared? It's 9 over 4. Okay, it's 9 over 4. So both sides, we have to add this number, right? This number. So x squared plus 3x is 1/2. And both sides, we want to add this number 9 over 4, 9 over 4. So we can change, now we can change the left hand side to this perfect square, x plus b over 2 squared. So it's x plus b over 2, 3 over 2 squared is, this side, we need to change the common denominator, so this is 2 over 4, so we got 11 over 4. Okay, 11 over 4. Taking square root, positive, negative, so we got x plus 3 over 2 is positive, negative, square root of 11 over 4. Okay, so this is positive, negative. So let's write down one more step here. X plus 3 over 2 is positive, negative, square root of 11 over 2. Okay, denominator, you can take simplify radical 4 to 2. Okay, to 2. So now we have two cases, right? We have two cases. So first, x plus 3 over 2 is positive 11 over 2. Second case, x plus 3 over 2 is negative square root of 11 over 2. So now minus 3 over 2, 3 over 2. We got x1 is negative 3 over 2 plus radical 11 over 2 minus 3 over 2 minus 3 over 2. We got the second solution, x2 is negative 3 over 2 minus square root of 11 over 2. Okay, square root of 11 over 2. So this is the steps to solve, to use completing square method to solve quadratic equation. Okay, solve quadratic equation. So let me repeat, right? Let me repeat. So what is step 1? Okay, what is step 1? Step 1, make, this is our step 1, right? Move C term and divide by A. Okay, divide by A. So this is the step 1. We got ax plus bx. Okay, bx. And step 2, completing the square. This is the completing the square method. This is step 2. Okay, change binomial to a perfect square. Okay, perfect square. And step 3, take positive, negative square root. Okay, step 4, solve the linear equation. So here is a step 4. Okay, here is a step 4. So this case, completing the square method is not easy. Okay, it is not easy. So let's quickly try another example. Okay, let's quickly try another example. An easier one. Okay, an easier one. Okay, yeah, so this is the standard form. So step 1, move C divided by A. Move C to the right hand side and divide by A. Okay, so plus 1, we got 2x squared plus x is 1, divided by 2, we got x squared plus 1/2 x is 1/2. Okay, is 1/2. So this is our completing square method now. So what is our B? Step 2. Our B is 1/2. So b over 2 is 1 over 4. b over 2 squared is 1 over 16. Okay, 1 over 16. Don't be scared, okay? It's not that hard. Later you will see the answers are very good, okay? The answers are very good. So this is in the number for completing square method. Okay, completing square method, we change x squared plus bx to x plus b over 2 squared. Okay, so that's our step 2. A is 1, and then we use b over 2 squared. So both sides add 1 over 16. So x squared plus 1 over 2x plus 1 over 16 equals 1 over 2 plus 1 over 16. Okay, 1 over 16. So now we can rewrite left to the square, right to the square. So it's x plus 1 over 4 squared. Okay, why is 1 over 4? Because b is over 2 is 1 over 4. Okay, yeah. So this equals to 1/2 plus 1 over 16. So 8 over 16 plus 1 over 16. So it's 9 over 16. Okay, 9 over 16. So step 3, take positive negative square root. So we got x plus 1 over 4 is plus minus radical 9 over 16. So what's 9 over 16? Radicals? 3 over 4, right? 3 over 4. So x plus 1 over 4 is positive negative 3 over 4. Okay, so step 4 we got two solutions, right? Step 4 we got x1 and x2 separately, right? Separately, two cases, okay, two cases. So for x1, so x plus 1 over 4 is positive 3 over 4. Okay, so minus a quarter, we got x is 2 over 4, so x1 is 1/2. The second case, x plus 1 over 4 is negative 3 over 4. Minus 1 over 4, minus 1 over 4, so x is negative 4 over 4, x2 is negative 1. Okay, it's negative 1. So we did get two good solutions, 1/2 and negative 1. So this is our beginning example. You see factoring method is much easier, right? So let me remind you what's the factoring method for this example, exactly the same example. So we factor the left hand side. This is 2x, this is x, and then we want this is plus 1, this is minus 1, right? So this is a part, b part, and the product is 0, so this is 0 and the other one is 0. 2x minus 1 is 0, so 2x is 1 divided by 2, x1 is 1/2. X plus 1 is 0, minus 1, so x2 is negative 1. You see, if you can factor a problem, if you can factor the ax squared plus bx plus c side, factoring method is much easier than the completing square method. Okay, completing square method, we have 4 steps. Okay, we have 4 steps. So if you can factor it. If you can't, you can use completing square method, or you can use our third method, the formula, okay, the quadratic formula. So let's look at the quadratic formula. Okay, so for any quadratic equation, ax squared plus bx plus c equals to 0. So here the condition is a is not 0. Then we have the solution, a formula for the solution. Okay, so what's this plus minus sign means? That means we have two solutions. The first solution, we have plus sign, so negative b plus is radical b squared minus 4ac. Okay, and then the second solution, we use minus sign in the middle before the radicals. Okay, so if you know ABC, just plug in, you got the answer. Okay, you got the answer. So let's look at the previous example again, right? Previous example again with this formula. Okay, with this formula. Okay, so our example is 2x squared plus x minus 1 is 0. Okay, it's 0. So again, before you use the formula, you have to make sure right hand side is 0. Okay, right hand side has to be 0, and then you have ABC, right? ABC. So what is A here? A is 2. What is B? B is 1, and C is negative 1. Okay, C is negative 1. If you cannot factor, and if you cannot use completing square method to do it, because here A is not 1, right? It's harder. Okay, it's harder. Just remember the formula and plug in. Right, plug in. So now let's replace ABC in the formula. A is 2, so here you have 2 times 2. B is 1, so this is negative 1. Okay, this is negative B, not B. Okay, and then plus minus square root of B squared, so it's 1 squared minus 4 times A, so 4 times 2, times C. C is negative 1. Okay, so just calculate. Okay, just calculate this. Let's simplify the radical part a little bit. Denominator 4, 2 times 2. So radical part, we need to simplify this, right? So what's under the radical sign? Let's put it here. 1 squared minus 4 times 2 times negative 1. So 4 times 2 is 8. So this is 8 times negative 1, negative 8. So 1 minus negative 8. So this is 9. Okay, this is 9. So this is plus 9 is radical 9. Okay, radical 9. So later we will give a name to this part. The part under the radical sign is called discriminant of the quadratic formula. Okay, yeah. So this is negative 1 plus minus radical 9 is 3 divided by 4. So now we can write down two solutions. X1 is, use plus sign, negative 1 plus 3 over 4. So this is 2 over 4, which is 1 half. X2 is negative 1 minus 3 divided by 4. So x2 is negative 4 over 4, which is negative 1. Okay? Negative 1. So this is our third method. Okay, third method, quadratic formula. You just need to remember the formula and then do it. Okay, and then do it. Okay, yeah. So the second and third method can solve any quadratic equation. Okay, first method, factoring method, only can solve some quadratic equation. Okay, some quadratic equation. So now let's look at this b squared minus 4ac. Okay, b squared minus 4ac. So this part under the radical sign is called the discriminant of the quadratic formula. Okay, the discriminant. So the discriminant tells us how many solutions this quadratic formula or quadratic equation will have. Okay, case 1. If this b squared minus 4ac is bigger than 0, then we get two solutions, x1, x2, two different solutions. Case 2. If b squared minus 4ac is equal to 0, then we get only one solution, x1 is equal to x2. Okay, because you are taking a square root of 0 here. So square root of 0 is 0, so we got only the part without radical sign. So this is negative b over 2a. Okay, so case 3, if this is less than 0, okay, then we got no real solutions, but we got two complex solutions. Okay, so the answers are complex numbers, which means there's a letter I here. Okay, you don't have real solutions. Okay, real solutions. So now let's look at an example that you have complex number as a solution. Okay, two complex solutions. Okay, two complex solutions. That's our last example today. Okay, yeah. So the question looks like very easy. It's x squared plus x plus 1 is 0. So what's our ABC? A is 1, B is 1, and C is 1. Okay, C is 1. You cannot factor this left hand side. Okay, if you like, you can try completing square method. Okay, yeah. So now let's look at quadratic formula method. So what is x? X is x1, x2 is denominator to a, this is negative b plus minus square root of b squared minus 4ac. Okay, so the discriminant b squared minus 4ac is the key. Okay, it's the key. So what's b squared minus 4ac for this example? ABC are all number 1, so this is 1 squared minus 4 times 1 times 1. So this is 1 minus 4, which is negative 3, less than 0. Okay, less than 0. So now let's plug in, right? This is negative 3. Okay, negative 3. So x1, x2 is 2 times 1, 2 down here, right? Negative b is negative 1. And then plus minus radical, the discriminant, negative 3. Okay, negative 3. You see, we're taking square root of negative number. So last time we talked about complex numbers. What's square root of negative 3? We use letter I. And then change square root of negative number, radical negative 3 to radical 3. Okay, what is this I? I squared is negative 1. That's the imaginary number. Okay, imaginary number, remember? Yeah. So now we have two solutions. Use letter I here, right? So this is radical 3i over 2. So what are two solutions? x1, we use the plus sign, negative 1 plus radical 3i divided by 2. And x2 is negative 1 minus radical 3i divided by 2. Okay, divided by 2. So for this quadratic equation, there are no real solutions. Okay, x1, x2 are not real numbers. They are fake numbers because there's a letter I here. Okay, not a real number. Okay, yeah, so for any quadratic equation, you just use this formula. You can get two solutions. Okay, two solutions. Sometimes they are both real numbers. Sometimes they are the same value. Sometimes they are both complex numbers. Okay, complex numbers. Okay, so that's our today's lecture.